Okay, so estimating roots, we're looking at inverse operations. So we just said the opposite of adding is subtracting. And so those are also considered inverse operations. What's the opposite of multiplying? Dividing. So those are also inverse operations. Okay, what's the opposite of squaring? What did we talk about yesterday? Square rooting. Right. So I'm just going to use the symbol, not going to use the words. Okay. Opposite of cubing, we did yesterday. We just gave it away. Cube rooting, right? So remember, square roots are so common that we don't have to put that little 2 there. So given that pattern, if we're raising a number to the 4th power, the inverse operation is taking the 4th root. So instead of a little 3, it's a little 4. Instead of a little 4, it's a little 5 for the 5th root and 6th root. Okay. Oh, sorry. N. That's N. So that's an N that goes there. Basically, N can represent any number. If it's a 2, if N's a 2, you don't have to show it because it's the most common one. Okay. So inverse operations also work in the opposite direction. So that's why I just said I think of them as opposites as well as inverse. So if we had to solve for x, where root of x is 8, we need to undo the square root. So that means we'd square 8 to get 64. So x would be 64. We're doing the opposite. Since the nth power is the inverse operation of the nth root and vice versa, it's true that every positive number can be written as a square root of its square. So 4 is the root of 4 squared. Cube root, 4 is the root of cubed root of 4 cubed. And remember that we always take the positive root when we have a root symbol. Okay, so terminology here for powers. The base is that big number that's at the base, and the little number is the exponent. That tells you how many times you multiply the base together. Okay, then the index is the little number in the root. Okay, so you have to know this terminology. So what's the index of the 4th root? It's 4. The radical sign, obviously, and the radicand is the number you're taking the 4th root or nth root of. So got to know those words. Okay, so I want you to fill in these values here. We already did some of these yesterday, right? The n squared, n cubed, where n is 1, 2, 3, all the way up to 10. But extend that to n to the 4th and n to the 5th. And try to challenge yourself without using your calculator. Okay? So I do all the squareds first, then the cubes, and so on. Okay, so refer back to this table, because remember, we're trying to do things without a calculator. Okay, Mateo, are you all right? Oh.
I'm good.
All right, so I'm going to estimate roots. So when you're not using a calculator, okay, so I need quiet. So 20 is not a perfect square. It wasn't in your list. So you want to think about ordering. So a number that you want to think about a radicand that's a perfect square that's close to 20. The one lower and the one above it. So 16 is a perfect square that's less than 20, the closest one. And 25 is the perfect square that's greater than 20. With the root symbol, so this is in order. So that means root 20 is less than 5, greater than 4. I'm using those inequality signs. Okay? Then, so you know your estimate is between 4 and 5. Are you going to do something really close to 4? Kind of in the middle? Really close to 5? Well, look at 20. How does it compare to 16 and 25? It's kind of in the middle, right? So my estimate would be, I'm going to use the approximate symbol. One of them is with a dot above. Sometimes you'll see a little tilde, and that means I'm going to estimate at 4.5. Okay. Take a look at the next one. It's a fraction. We did some perfect square ones yesterday that were fractions. This is the same as that. I can simplify the denominator. Root of 4 is 2. And so now I'm going to think of root of 45 over 2. What is it close to? So the 2 I'm going to keep, and then 45. So root of 45. Look back on that chart if you need to. What's a perfect square that's close to 45? Well, 49 and 36. So now my estimate for this, oh, I guess I should simplify each of those. So this would be 6 over 2 and the outside one would be 7 over 2. Well, 6 over 2 is 3, right? But you might not even want to simplify that yet. I'm just going to keep it as the root 45. So root 45 is between 6 and 7. Take a look. So that's what? That's about 9 apart. That's 4 apart. So it's a little bit closer to 7. So I'd say root 45 is about, I don't know, maybe 6.6, 6.7. Maybe I'll say 6.7 over 2, which dividing that by 2 is what? 3.35. So somewhere between 3.3 and 3.4. Maybe we should close one of those two windows because it's going a little nuts. You can leave it a little bit open. Okay, so now what do we do for cubed roots? We have to look at the next column in that chart for perfect cubes. And so here, cubed root of 58. Okay, so in the perfect cubes, 64 is the next largest perfect cube that's greater than 58. And 27, if you look back, let's just check here, but 27 is the next lower one. Okay, and so that's 3. And that's 4. So it's between 3 and 4. And then you want to look, is 58 closer to 27 than 64? No, it's closer to 64. So yeah, so maybe 3.7. Okay. So you do the next one. That's a 4th root. So you're going to use the column that has the powers of raised to the exponent 4. Okay. And this one is between 3 and 4. But if you look at 130, it's a little closer to 81 than 256. So I would maybe estimate 3.3 or 3.4. Oh, I'm not going to bother putting that. Just a sec. Okay. So there would be, like if this was on a test that you had no calculator, we'd probably be a little bit lenient, 3.3, 3.4. But if you put 3.6, it's like, no. Because we're estimating. It's close to being halfway in between, right? Okay, so number line on this one. It says use a number line to order these numbers from least to greatest. So that means just don't just put them in order from least to greatest, put them on a number line. Okay, so when I do that, I think about, now look at all of these. They are, 2 of them are square roots. and one of them is a cubed root. So for sure, root 12 is less than root 19, right? 16 is a perfect square, so that's 4. I'm gonna, and they're all positive, so maybe I start labeling 0, 1, 2, 3, 4, 5. It's not going to go bigger than that, right? Just for a number line. And then, so root 12 is between root 16 and root 9. Okay, so between 3 and 4 again. We seem to, when we made up these questions, like those two numbers, 3 and 4. A little bit closer to 3, right? So that's going to be maybe around there. We don't have to say exactly. We'll just label it, root 12. Root 19. So I'm just starting with the square roots. That's between root 16 and root 25. So between 4 and 5. Okay, again, a little bit closer to 16, so I'd say it's probably about there. And then cubed root of 9, so it's cubed root. So then 9 is close to 8, so it's greater than cubed root of 8, and then less than cubed root of 27. It's 9 is very close to 8. So it's just a little bit more than 2. So it would go here. Okay. If it didn't ask for a number line, then you just put them in order. Okay, so I'm going to give you a few minutes to do some of the practice there underneath. And then, as I mentioned, we're going to look into actually starting to simplify radicals. So, because this lesson is pretty short. We gave it a day, but we really shouldn't have given it a day. And so that's all that the practice is, questions 1 and 2. From the booklet, there's obviously some from the textbook. So I want you to work on that right now, and then maybe in about 10 minutes, we'll look at mixed and entire radicals.